All right, everybody, so what you can see here is we're going to do something similar to what we did in VexCode VR with the wall bouncer assignment, but we're replacing the walls with just blue tape. So we're going to make it bounce around in random directions infinitely with blue tape and a color sensor that's facing down. So you'll need to make sure before you do this you've added the color sensor. There should be a video in the Canvas assignment that shows you how to do that. All right, so let's check this out. We'll stop this guy here. Mr. Woodchick actually benefits from Bluetooth, so I can kind of send them automatically. The student computers don't have that, so you'll have to use USB. All right, so let's go ahead and we're going to get started on this one. Okay, and let's just zoom in a bit so we can see this code a little bit larger. You don't need to be too small. All right, so first thing we need to do, as with anything, remember Legos can be used for all sorts of different machines. So we have to tell it where our motors are plugged in. You can see mine's still connected with Bluetooth. And if you have yours connected to the computer correctly with USB, you should see the same data. You can see my motors are plugged into C and D. So let's go to the movement tab first, and we need to tell it where our motors are plugged in. Mine are C and D. So I'll just leave that alone. That looks fine for me. And okay, and for stuff like this, we don't want overshoot, which means by the time the robot stops, it's way past the wall. So we don't want to overshoot on this. So what we're going to do is we're going to slow things down quite a bit. So set the movement speed. Let's set that to 25%. Okay, and the next thing we need to do is we need to tell it, remember, since we're going to be using distance measurements for how far the robot moves backwards when it detects the line, we need to tell it how big of motors we have, or how big of wheels we have. The wheels that we're using should be fine at 17.5 centimeters. So just snap that on, and this gets all of our stuff set up. Okay, cool. So that should get that done. And let's go ahead and do the rest of our code. So we're going to start off by waiting until a button is pressed. Where did it go? Here it is. I'm going to use the left button. You could, of course, press that to right button. You can also change this to wait until it's released if that matters, but I don't think for our stuff, I don't think that matters very much. Okay, so this is going to get it set up. This automatically sets everything up right when you run the program. And this one is waiting for you to press the button to actually execute the code. Okay, so let's go back up to control. Let's go down to control, let's click on control, and we need a repeat forever loop. Again, if you can remember, this robot kept doing that again and again. It just keeps going and going until we stop it. Luckily, he's not very fast, so it's easy to grab it and turn the thing off. All right, so let's go. First of all, we got to make this thing move. But the problem is we don't really know how far it needs to move. Usually we would use this one to move and we would set rotations, number of seconds, or maybe even centimeters. We're not going to do that. We're going to tell it to go forward because we don't know how far, since everything's random and it happens infinitely, we have no idea on each iteration how far the robot needs to go. So we're just going to tell it to start moving forward. You could think of it as having ... until something else, okay. So let's do that, and we're going to go down to here, and something else is going to happen. And we're going to wait until, so there's our wait until block. And we're going to wait until that color sensor that's facing down that we added to our robot that looks straight down at the ground. We want to wait until that color sensor, so go down to sensors. And here it is. This is the color sensor block. Remember, when you snap these in, don't try to snap this end in. Aim with this end of it. And there, see it lights up, let go, and it snaps in. And we don't want red. Our tape in this case is blue. If I have black tape or some other type of tape, when you do this, I'll tell you. So you might have to select a different color. Right now we're using blue tape, so I'm going to click the blue one. So we're going to start moving and wait until it hits that blue tape. Okay, cool. So let's go to the next part. And we want to go back to movement. And when it hits the tape, we want it to stop moving completely. And we want it to wait and settle and wait. So we're going to have it wait and go down back to control. And we're going to wait. I think 1 second is excessive and it would slow your program down. I'm going to go 0.5, so a half a second. You can do that, and I think 1 second just kind of slows things down a lot. Okay, let's go back up to movement. What are we going to do? If we remember from our lab on VexCode VR, when we hit the wall, we moved backwards, okay? And so we're going to go ahead and move backwards. So let's go to movement. Movement. So when that happens, we've detected the line, we stopped at the line, we don't want to go over it, we wait, and then we're going to have the thing move backwards. You have to change this to a backwards down arrow. And how far are we going to go? We're going to change this to 4 inches, or you could choose 10 centimeters. Those are almost the same thing. Very, very close. Okay? All right, cool. So, hey, that's great news. We're ready to move on. But once we move back, now we get to the part that's probably the hardest part of the program, but it's not that difficult. But I will have to show you some things to help you to understand this. So, when we move back, we want to move and turn right. So once we've detected it, we move back, and then we turn right. And we're going to go move right. We want to change this to a very sharp, perfectly sharp turn. Right 100. Now, we know our robot is going to turn right or left randomly. Don't worry, I'll show you how to do that right now, after I explain to you how degrees turns work in this program. This is a very, very common mistake that people make when they're dealing with these sorts of robots. So what we need to do to understand the way that, because we're going to be using degrees here, we first need to understand how that works, and then we'll compare it to some of our old data, and we'll start working with that. There's a good reason why we're doing this, is because a random number generator on here will round to whole numbers typically. And it makes it kind of difficult to do this with rotations. Although it's not impossible, we could do some math. We're going to do it a little different way just to kind of explore how these work. So I'm just going to put this up here, and I'm going to notice how this indicator, this turn indicator, the white flag, I guess you could call it, is facing straight up and down. So let me pause this and take a screen cap. Okay, so let's take a look at this. When we did our lab, if you can remember, when we calibrated gyroscopic turns to be exactly 90 degrees, when we did our maze lab, that was like, we would consider that robot to be kind of dumb and blind, right? It had no sensors on it at all. We just told it exactly how far to go through. It's kind of like a person who's blindfolded. Walk forward 5 steps. So there's no feedback from sensors detecting anything in the environment around, but we just did basic turns. And we figured out from that, if you remember, let me get this brush correct here. So if we remember, I'll go straight up and down is where this thing would start, right? Whoops. Okay, and remember what we really wanted. In that lab, what we figured out is that this wheel spins half of a rotation. So let's take, it goes from here, and it goes around, whoops, we need to make that bigger. And it goes around this way, keep spinning. That's a bad arrow, sorry. And we end up right here, straight up, we end up here. Remember when we figured out in that lab, we figured out that a half of a rotation, so this is, if we go to all the way to the bottom, that would be 0.5 rotations. But isn't that the same as actually spinning the wheel? And remember, when Lego talks about degrees, they're not talking about the turn that the robot makes. They're talking about the degrees that the wheel rotates. Now, how far is that going to make? It depends on your robot. But our robots, what everybody found in that lab, pretty much what I saw, was that 0.5 rotations, let's move this up a bit, is that 0.5 rotations got us to a turn, a robot turn, 90 degrees. Right? So half of a rotation turned our robot a 90-degree turn, and then we could go and complete our maze, right? So every time this wheel spins half of a rotation, it spins the robot turns 90 degrees. By the way, this is the same as the wheel turning 180 degrees. Now that's crazy. There's a difference, right? The wheel does a half turn. Log out of my computer. Your new seat's going to be over here. What are you playing with? Oh, okay. No problem. Sorry.